distant blue world drifts silently at the edge of our solar system. For decades, it seemed calm, cold, and almost lifeless. But new observations have begun to reveal something strange happening high above this planet's clouds. Something powerful is twisting and shaping its atmosphere in ways scientists never expected. Recent observations using the powerful James Webb Space Telescope have allowed researchers to look at Uranus in an entirely new way. For the first time, scientists have mapped parts of its upper atmosphere in 3 dimensions, tracking how temperature and charged particles move through its thin outer layers. What they found suggests that powerful magnetic forces may be warping the planet's atmosphere, bending it and heating it unevenly across the globe. Uranus has always been one of the most mysterious planets in our solar system. It sits nearly 3 billion kilometers from the Sun, far beyond the orbit of Saturn and Jupiter. From Earth, it appears as a pale blue disk, quiet and distant. But beneath that calm appearance lies a world that behaves very differently from any other planet we know. The story of Uranus begins in 1781, when the German-born astronomer William Herschel was scanning the night sky with a homemade telescope. At first, he believed he had discovered a comet. But as he continued observing the object, its movement revealed something far more extraordinary. It was a new planet, the first one discovered in modern history. For centuries, Uranus remained little more than a distant point of light. Even the most powerful telescopes on Earth could reveal only faint details about its atmosphere and structure. Scientists knew it was classified as an ice giant, a type of planet composed largely of water, methane, and ammonia ice deep inside its interior. The methane in its upper atmosphere absorbs red light from the sun, giving Uranus its distinctive blue color. But many of its features remained unknown for a very long time. The planet rotates in an extremely unusual way. Instead of spinning upright like Earth or Jupiter, Uranus is tilted dramatically on its side. Its axis is tilted about 98 degrees, meaning the planet essentially rolls around the sun as it orbits. This strange tilt creates the most extreme seasons in the solar system. Each pole experiences about 42 years of continuous sunlight, followed by 42 years of darkness. Entire hemispheres spend decades either fully illuminated or completely frozen in night. Scientists believe this extreme tilt may have been caused by a massive collision early in the planet's history. Billions of years ago, a planetary-sized object may have slammed into Uranus, knocking it onto its side and permanently changing the way it rotates. Despite this dramatic past, Uranus remained one of the least explored planets in the solar system. Only a single spacecraft has ever visited it. In January of 1986, NASA's Voyager 2 probe flew past Uranus during its long journey through the outer solar system. The images returned by Voyager 2 surprised scientists. Compared with Jupiter and Saturn, now which are covered with colorful storms and swirling clouds, Uranus appeared almost featureless. Its atmosphere looked smooth and calm, like a pale blue marble floating in darkness. But Voyager 2 did reveal something unexpected. Uranus possessed a magnetic field unlike any other in the solar system. On Earth, the magnetic field is generated deep inside the planet's molten iron core. The field is roughly aligned with Earth's rotation axis and centered within the planet. This creates a relatively stable magnetic environment that surrounds the planet like an invisible shield. Uranus, however, is very different. The magnetic field of Uranus is tilted dramatically, about 59 degrees away from the planet's rotation axis. Even more strangely, the magnetic field is not centered within the planet. Instead, and it is shifted far away from the center, as if the magnetic engine generating the field is displaced toward one side of the planet. This unusual structure creates a chaotic magnetic environment. As Uranus rotates, the magnetic field wobbles and twists through space in a complicated pattern. Charged particles from the Sun interact with this magnetic field in unpredictable ways. For decades, scientists struggled to understand what this meant for the planet's atmosphere. Without continuous spacecraft observations, many questions remained unanswered. That situation began to change with the arrival of a new generation of space telescopes. The James Webb Space Telescope, launched in 2021, is the most powerful space observatory ever built. Positioned nearly 1.5 million kilometers from Earth, this Webb observes the universe primarily in infrared light. This allows it to detect heat signatures and faint atmospheric details that are invisible to ordinary telescopes. Although Webb is best known for studying distant galaxies and the earliest stars in the universe, it has also become an incredibly powerful tool for studying planets within our own solar system. When scientists turned Webb toward Uranus, they were able to capture an extraordinary level of detail. The telescope's sensitive instruments allowed researchers to examine the structure of the planet's upper atmosphere with unprecedented precision. By analyzing how infrared light passed through different layers of gas, scientists could measure temperatures at various altitudes and track how energy moves through the atmosphere. Then this data allowed them to create a three-dimensional map of Uranus's upper atmosphere for the first time. Instead of appearing uniform and calm, the atmosphere showed complex patterns of temperature differences and energetic activity. Certain regions were significantly warmer than expected, while others appeared cooler and more stable. Even more intriguing was the movement of charged particles interacting with the planet's magnetic environment. These particles follow invisible magnetic field lines that extend from the planet into space. When they collide with gases in the upper atmosphere, they transfer energy that can heat the surrounding regions and create glowing auroras. On Earth, auroras appear as shimmering curtains of green and red light near the poles. They are produced when charged particles from the solar wind collide with atoms high in the atmosphere. Uranus also has auroras, but because of its unusual magnetic field, they behave very differently. Instead of remaining confined near stable polar regions, auroral activity on Uranus can appear in shifting locations across the planet. As the tilted magnetic field rotates, different regions of the atmosphere become connected to incoming streams of charged particles. This causes bursts of energy to appear in unexpected places. The new observations suggest that these magnetic interactions may be shaping the planet's upper atmosphere in dramatic ways. When charged particles travel along magnetic field lines and collide with atmospheric gases, they release energy in the form of heat. This heating process does not occur evenly across the planet. Instead, it happens wherever the magnetic field channels these particles toward the atmosphere. Because the magnetic field of Uranus is both tilted and offset, the regions receiving this energy can shift as the planet rotates. Over time, this uneven heating can cause the atmosphere to expand, contract, and move in unusual patterns. Scientists believe this may explain some of the strange temperature variations observed in the new atmospheric maps. Certain regions appear warmer than expected because they are receiving bursts of energy from incoming charged particles. Other areas remain cooler where fewer particles interact with the atmosphere. The result is a complex and constantly changing atmospheric structure that appears warped and distorted compared with simpler planetary atmospheres. Another factor influencing this process is the solar wind. The Sun constantly releases a stream of charged particles that travel outward through the solar system at high speeds. When these particles encounter a planet's magnetic field, they are forced to follow curved paths around it. On Earth, the magnetic field deflects most of the solar wind, protecting the atmosphere from direct bombardment. But at Uranus, the tilted magnetic field creates unusual entry points, where solar wind particles can slip into the planet's magnetic environment. When this happens, bursts of energy can cascade down magnetic field lines into the upper atmosphere. And these events can temporarily heat regions of the atmosphere and trigger intense auroral activity. Because Uranus rotates on its side, the orientation of its magnetic field relative to the Sun changes dramatically throughout its orbit. At certain times, the magnetic field may point almost directly toward the solar wind, allowing more charged particles to enter the system. At other times, it may be oriented in a way that reduces the interaction. This constantly shifting geometry makes Uranus one of the most complex magnetic environments in the solar system. The new observations from the James Webb Space Telescope are helping scientists unravel this complicated relationship between the magnetic field, the solar wind, and the planet's atmosphere. Researchers are beginning to see how these forces interact to create a dynamic environment far above the planet's cloud tops. Understanding this process is important because Uranus represents a type of planet that is extremely common throughout the galaxy. Astronomers studying exoplanets have discovered that many distant worlds appear to be similar in size and composition to Uranus and Neptune. These ice giant planets may be among the most common planetary types in the universe. Yet within our own solar system, they remain among the least understood. By studying Uranus in greater detail, scientists can gain insight into how these planets form, how their atmospheres behave, and how their magnetic fields evolve over time. The new three-dimensional atmospheric mapping represents an important step in that direction. It shows that Uranus is far more active and complex than its calm appearance once suggested. The atmosphere of this distant world is constantly being shaped by invisible forces flowing through space. Magnetic fields twist through the planet's environment, guiding streams of energetic particles that heat and reshape its upper layers. These discoveries are also renewing interest in sending a new spacecraft to explore Uranus directly. Many planetary scientists believe that an orbiter mission could reveal far more about the planet's interior structure, magnetic field, atmosphere, and moons. Such a mission could spend years studying how the magnetic field interacts with the solar wind and how energy moves through the planet's atmosphere. By observing these processes up close, scientists could finally understand why Uranus behaves so differently from the other planets in our solar system. Until that happens, powerful telescopes like the James Webb Space Telescope will continue providing glimpses into the hidden dynamics of this distant world. Each new observation adds another piece to the puzzle, revealing a planet that is far stranger and more fascinating than anyone once imagined. A silent blue giant drifting at the edge of the Sun's domain, slowly rotating on its side, wrapped in a magnetic field unlike any other. And now, with new eyes watching from deep space, scientists are beginning to see that something powerful is shaping its atmosphere, bending invisible currents of energy through the skies of a world that still holds many secrets waiting to be discovered.